Oh no. Oh no. It's okay though, Mr.
All right, so
Morrison. It's okay.
what's that? Okay, so secant
It's all good.
of 45 degrees. Thank you. I'm sure you guys are all helpful. If someone is missing it, they could get the first part of the notes from you guys. All right, so hypotenuse is square root of 10 over the adjacent side, which is square root of 5. So for my final answer, to make sure you always simplify your final answer. When you're multiplying or dividing radicals, you can just multiply or divide the numbers under the radical. So 10 divided by 5 is 2. So this just becomes the square root of 10 over 5 is the square root of 2. So that tells you the ratio of the hypotenuse to the adjacent side. Square root of 2, or over 1, or just square root of 2. Are we doing okay?
I'm doing fantastic, Mr. Morrison.
What I like to hear. Thank you for the feedback, Ethan. Okay, so coming over here now, we're going to go beyond the unit circle again. So remember, you don't have to limit yourself to a radius of 1. So think of this as like a circle. You don't actually have to draw the circle if you don't want to. But there's a circle here. Okay, so for this circle, I'm going to make a triangle. Right here, I'm going to do a perpendicular line to the x-axis, forming my right angle, and that creates a right triangle here. So for this right triangle, it's going to have one side from the origin. You're going square root of 15 to the right to get to the point. And you're going down 7. So let's put a negative 7 here. So using the given point, you know that these two sides, we talked about this from the previous lesson, to get from the origin to this point right here, you go square root of 15 to the right along the x-axis and down 7. So I'm going to call this side R because this represents the radius of a circle. It's also the hypotenuse of my triangle. So I'm going to do Pythagorean theorem here. So I'm going to do negative 7. If you did 7 squared, you'll get the same thing. Plus square root of 15 squared, that equals R squared. So Pythagorean theorem to solve for the radius. So this becomes 49 plus 15 equals R squared. This gives me 64 equals R squared. And the square root of 64, the positive square root, would just be 8. Because the radius has to be positive. So instead of an R here, I can change this R into an 8. And theta, you guys know how to identify the reference angle? So I'll use a different color here. Actually, I don't even know if I have room to fit it. So I'm just going to draw an arrow. So theta is going to be this angle right here. So that's the reference angle. It uses the terminal side and the closest part of the x-axis. So I'm hoping by now everyone is good finding the reference angle. So you need to know where the reference angle is here. So now that I have the reference angle, I can find sine of theta. I'll start with the 3 you learned in IM2. So sine of theta, cosine theta, and tangent theta. So based on the triangle that I have here, so this is my triangle. So the side opposite of theta is going to be negative 7. I'm going to keep it as negative 7 so I don't have to worry about which quadrant I'm in. You can also think quadrant 4. All students take calculus. You know cosine is positive and everything else is negative. Well, if cosine is positive, its reciprocal secant also must be positive. So if you wanted to think of all students take calculus, it'll look like this. So all students take calculus. So quadrant 4, cosine is positive. Everything else is negative. So sine and tangent. That means the reciprocal of sine is negative and the reciprocal of tangent is negative. Whenever you take a reciprocal, that never changes the sign. So, but cosine is positive. That means its reciprocal secant must also be positive. So it doesn't matter if you take care of the sign at the beginning or if you just leave this as -7, you don't even have to worry about all students take calculus. Leaving that as -7 will take care of itself. Okay, so now my sine is opposite over hypotenuse. So that's going to be 7 over square root of, no, 7 over 8, just kidding. So opposite over hypotenuse is 7 over 8. Cosine is adjacent over hypotenuse, so that's going to be square root of 15 over 8. So this is already simplified here. This one's already simplified. Tangent is opposite over adjacent. So that'll be -7 over square root of 15. So this one is not simplified because you have a radical in the denominator. So I'm going to multiply the top and the bottom by square root of 15. So this becomes -7 times the square root of 15 over 15. So that's our sine, cosine, and tangent. Notice how I lined them up. I put the reciprocal directly on the right. That just makes it easier for you. So now you don't have to think. You're just, whatever you have here, you take the reciprocal of that. That goes directly to the right. So the reciprocal of -7 over 8 is -8 over 7. The reciprocal of square root of 15 over 8 is 8 over square root of 15. And that, you should all know, is not simplified because it has a radical in the denominator. So I'm going to multiply the top and the bottom by the square root of 15. So this gives me 8 times the square root of 15. I times the top by the square root of 15. When you times the bottom by the square root of 15, it's just 15. Hopefully I have enough room here. Okay, then for cotangent, we know it's negative. So I'm going to actually take the reciprocal of this one. So I don't have to do any simplifying work. So when I take the reciprocal of -7 over square, even though that wasn't my final answer, when I take the reciprocal of that, I won't have a radical in the denominator. So this will be negative square root of 15 over 7. No simplifying needed here because it's already simplified. So we have one more example to do, but I definitely want to take any questions you have before I clear out the screen. Okay, hopefully we're still doing all right. Definitely speak up. Make sure your mic is turned on if you have any questions. Don't be shy. Okay, so we're going to keep going to cotangent of 30. So this one's interesting because normally you need 2 sides to find the third side of a right triangle. But this one we only need 1 because this is a special right triangle. So for a special right triangle, you can use the relationship between the pairs of sides. So I'm going to write out the 2 formulas we did back in 18.0. So hypotenuse, remember how I abbreviated it back in 18.0 notes? The hypotenuse is 2 times the side length. And the long leg is the short leg times radical 3. So my hypotenuse would be here. The short leg is always opposite the 30. So that means 10 is the long leg. So the long leg, please remember, is always opposite the 60. So there's, you know, this would have to be 60 degrees here. So the angles add up to 180. So the long leg is always opposite the 60. The short leg is always opposite the 10. So using these 2 formulas from our 18.0 notes, the first equation is not going to help me because right now I don't know h and I don't know s. So I'm going to use the second equation. So 10 is my long leg, has to equal the short leg times radical 3. Then I'm going to divide both sides by radical 3. Whoops, what am I doing? It's 10 divided by radical 3. Then I'm going to times the top and the bottom by the square root of 3. So S, my S's look like 5, so that's an S, equals, I times the top by radical 3. When you times the bottom by radical 3, it's just 3. So I can take this, plug it in for S, and then I can solve for my hypotenuse. So the hypotenuse is just going to double that. So it's 2 times 10 radical 3 over 3. So the hypotenuse just becomes 20 radical 3 over 3. So now that I know all 3 sides, I can find cotangent of 30. You know what? I didn't even need my hypotenuse, because cotangent is the reciprocal of tangent. Tangent doesn't use the hypotenuse. It's opposite over adjacent. So I just found the hypotenuse for fun, but that's okay. So to find cotangent of 30, it's going to be adjacent over hypotenuse. This is the reciprocal of tangent. So I'm focusing on 30 degrees. That's my reference angle. So we know the opposite side is 10 radical 3 over 3. We found that here. And then we know the adjacent side is 10. So I'd say cotangent 30 equals the adjacent side, which is 10, over the opposite side, which is 10 radical 3 over 3. So you guys remember mod 8, we did complex fractions when you have a fraction and a fraction. So one way you can simplify this, you could times by the reciprocal of the bottom. I'm just going to times the top and the bottom by 3. This is good algebra review here. So if I'm timesing the top and the bottom by 3, you're timesing by 1. Timesing something by 1 never changes its value. So on the bottom, when you times by 3, the 3's cancel out. So I'm going to rewrite this as cotangent of 30. Sometimes the hardest part of the problem is just simplifying. So that's going to equal 10 times 3 gives me 30 on top. On the bottom, I have 10 radical 3. So cotangent of 30 degrees equals 30 over 10 just becomes a 3. I'll leave it on top. And then I'm going to times the top and the bottom by radical 3 because I don't want to leave a radical in the denominator. So this lesson involves a lot of good practice for simplifying, a skill you absolutely need to have going into pre-calculus. It is a big jump going from IM3 to pre-calculus. So there's a lot of, there's a high level of expectation of what you need to know going into that class. So cotangent of 30 degrees equals, we have 3 radical 3 on top. On the bottom, radical 3 times radical 3 is radical 9, which is just 3. And then the 3's cancel out, and now I'm done. Cotangent of 30 degrees. So that was a lot of simplifying. Usually it's not that much work to simplify, but this one, it is. So cotangent of 30 equals square root of 3. If you want to check your answer on your calculator, so if you have a calculator, get that out now. I'll give you a few seconds. If that's close by, you can get your calculator out. Make sure you're in degree mode. I'm going to tell you what you can do now to check this answer on your calculator, and then we'll start the next lesson. Next lesson's a little bit shorter than this one, so that'll be good. And there's not really anything we have, other than we'll just check the homework at the end. Okay, so to check this on your calculator, make sure you hit mode. You should be in degree mode. So I'm going to do, instead of cotangent of 30, because it's the reciprocal of tangent, I'm going to do 1 divided by tangent of 30. It'll give me a decimal. If you want to make sure that square root of 3 is correct, just do square root of 3 and you should get the same decimal. So I don't know if you can see this, but both of them gave me 1.7 something. So 1 divided by tangent of 30 and square root of 3 both give me the same exact decimal on here. So that's how you would check on your calculator. But your calculator would never give you square root of 3, at least most calculators. Nor should they. You should be able to show all your work here. So any questions before we go on to the next lesson? Okay. I need to send you the assignments that are due next week. So I'll do that by the end of today. I'll send it with the video. Okay, so this is 18.4b now. So we're still working with the 6 trig ratios. So the top part of the page is mainly a review. One thing I do want to emphasize though here is that you should definitely know first day of pre-calculus. I keep talking about that, but that's important because, again, it's not like you just show up and the teacher's going to do this lengthy review. She has a lot of other things she needs to work on, so you're expected to know a lot of this stuff. So make sure you know that tangent is sine over cosine. It's the y-coordinate divided by the x-coordinate on the unit circle. Cotangent is the reciprocal, so that means it's cosine over sine. So on the unit circle, that would be the x-coordinate divided by the y-coordinate. And you can see off to the side how it gets simplified. Okay, so what do we have here? I'm actually going to go down so I can see all 3 parts. See how quick this is? Just do this one section, and then we're on to the last page of the notes. Okay, so you can see that there are 4 steps here. So everyone knows where their unit circle is in their notes. If you go back to the unit circle in your notes, at pi over 6, isn't cosine always the x-coordinate on your unit circle? You can use that left-hand trick I showed you the video of last time, which I finally got it to work at the end. So for cosine, or at pi over 6 on the unit circle, somebody tell me, what is the x-coordinate?
Square root of 3 over 2.
Square root of 3 over 2, thank you. So if you look at your unit circle, you locate pi over 6. Cosine is just, you have to know cosine is just the x-coordinate on the unit circle. So we are done. In quadrant 1, everything is positive, so you don't even have to worry about checking the signs. Pi over 6 is in quadrant 1. Okay, for tangent, that's going to be y over x. So if you locate on your unit circle, so you have to go back in your notes to, what was it, 18.2. Go back to 18.2C notes, you should be able to see your unit circle. So if you locate 7 pi over 6, that's in quadrant 3. Because you're in quadrant 3, all students take. That means tangent is going to be positive. So you take the y-coordinate at 7 pi over 6, or you could base it off of the reference angle, pi over 6. Either way is fine. Let me actually backtrack here. So 7 pi over 6, this is going to be, you take it's y over x. So the y-coordinate is negative 1/2 divided by the x-coordinate, which is negative square root of 3 over 2. And this is the most important thing you're going to learn all year in terms of preparing you for pre-calculus. You need to know your unit circle. I know the honors pre-calc teacher will have you, like, before she even lets you in the classroom, she'll say, like, what is tangent of 7 pi over 6? Before you can even get into class, you have to be able to tell her. She'll make you wait in line outside of your class. If you've ever seen students waiting outside of a class in the J building, that's probably what's happening. So a negative divided by a negative is a positive, which we know all students take. So this is going to be times the top and the bottom by 2. The 2's go away. So it's 1 over square root of 3. And then you times the top and the bottom by square root of 3 here. Your final answer is going to be square root of 3 over 3. So now we're going to take what we just learned about reciprocals and apply that to this one. So cosecant, someone speak up. What's the reciprocal of cosecant? Which trig function is the reciprocal of cosecant?
Sine.
Sine, thank you. So remember, sine is the y coordinate. So we're taking reciprocal of the y coordinate. So that would be 1 over y. So if you're asked to find cosecant, you're doing the reciprocal of the y coordinate. How you write the reciprocal of anything is 1 over that. The reciprocal of 2 is 1 over 2. The reciprocal of 2/3 is 1 divided by 2/3. So the reciprocal of y is 1 over y. So I'm going to locate 315 degrees on the unit circle. And you're going to get at 315. Well, first of all, we're in quadrant 4. So all students take calculus. So calculus, only C, only cosine is positive. That means sine is negative and its reciprocal is going to be negative. So my answer is going to be negative. So it's 1 divided by, and then it's going to be square root of 2 over 2. So square root of 2 over 2, or negative square root of 2 over 2 would be the y coordinate at 315 degrees. Okay, so I'm going to times the top and the bottom here by 2. So that's going to leave me with, to simplify a complex fraction, it's going to be negative 2 over square root of 2. I'm going to times the top and the bottom by square root of 2 now. So it's going to be negative 2 square root of 2 over 2. And the 2's are going to cancel out. So my final answer is going to be negative square root of 2. You should still be in degree mode. If you want to check this on your calculator, you would just do 1 divided by sine of 315, since it's the reciprocal of sine. So 1 divided by sine of 315. That'll give you a number, and then you do negative square root of 2, it should give you the same number. And that's how you know you did the problem correctly. So any questions before we go to the last 4 examples on the next page? It shouldn't take too long. It's a lot of the same stuff. Okay, I know it feels like a lot doing 2 sections, but it's once a week, so I think it's definitely manageable. I'm guessing you prefer this to doing 4 or 5 lessons in a week. All right, so I'm going to clear this out. Actually, it's on the next page here. I have to use a different document. Okay, so on the last page of notes, I can't believe we're finishing Mod 18 right now, and we just have a little bit more to do, not a lot. Okay, I was actually going to make up an example for the 4th example. Okay, so secant of 420. This is actually going to equal, remember we learned about coterminal angles. So trig is all about connecting everything together. That's so critical to understand how everything's connected. So I can say that this is equal to secant, if you subtract 360 from 420, this is going to be secant of 60 degrees. The reason I would do this, 420 does not show up on your unit circle. So you need to find a coterminal angle that does show up on your unit circle. So I'm going to define secant of 60, which is going to be the same ratio because it has the same terminal side as secant of 420. So this is the reciprocal of cosine, meaning it's 1 over cosine of 60 degrees. So you guys know how to find cosine of 60, correct? You locate your unit circle, you figure out where 60 degrees is, and you take the x coordinate. Cosine is always the x coordinate. So this equals 1 divided by 1/2. So if you do 1 divided by 1/2, if you want to make 2 cups of flour, or 1 cup of flour, and you have a 1/2 cups, how many 1/2 cups does it take to make 1 cup of flour?
2.
2. So there's 2 1/2 cups to make 1 cup of flour. So that's our answer. And if you can, this one will be easy to check on your calculator. Just do 1 divided by cosine 60. It should give you 2. Next one is in radians. You don't have any negative angle measures on your unit circle. So I'm going to add 2 pi to this. So if you add 2 pi to negative 5 pi over 2, that's going to give you 3 pi over 2. Because 3 pi over 2, this is what shows up on your unit circle. Negative 5 pi over 2 does not. So I'm doing negative 5 pi over 2. Everyone knows how to add 2 pi to that. 2 pi would be 4 pi over 2. So you have a common denominator. Wait, would that work?
I don't think so.
Just kidding. You'd have to add 4 pi here. Yeah, you'd have to add 4 pi because if you add 2 pi, it's still negative. So 4 pi would be 8 pi over 2. So when you add 8 pi over 2 to negative 5 pi over 2, that'll give you 3 pi over 2. So we said tangent is y over x. So that means cotangent is x over y. So you locate 3 pi over 2 on your unit circle. And then you do the x coordinate divided by the y coordinate. That's the reciprocal of tangent. You know tangent is y over x, so cotangent must be x over y. So if you look back to 3 pi over 2, you should see that the x coordinate is going to be 0. And then the y coordinate is negative 1. So 0 divided by anything is just 0, and we're done. So here, if you want to check on your calculator, you need to be in radian mode, and you would do 1 divided by tangent of negative 5 pi over 2, and that should give you 0. Because your calculator, unfortunately, does not do tangent. It only does sine, cosine, and tangent.
Mr. Morrison, I have a quick question. On the first one, how did you get
Yes.
60 degrees? I'm a little confused.
So I just did 420 minus 360. You can, when it's in degrees, you can add or subtract any multiple of 360, like 720, 1080, and it's going to have the same value when you do any of the 6 trig ratios. So this is going to give you a coterminal side. It's going to have the same ratio.
Okay.
And the reason you want to do that is because 420 doesn't show up on the unit
Okay,
circle,
thank you.
only 60 does. Okay, so
Gotcha.
tangent
And then how did you get
of,
I'm
go ahead, did you say something?
wait, sorry again, Mr. Morrison, for interrupting. Yeah, sorry again, but
It's okay.
I'm again a little confused. How did you get 3 pi over 2? Did you subtract
3 pi over
by
2, that's
2
okay.
pi?
I'll write it here. So
Or add 2 pi?
this one, if you add 2 pi, it'll still be negative. So for this one, I would add 4 pi. You can add or subtract any multiple of 2 pi. So this is going to be negative 5 pi over 2. I'm going to write 4 pi as 8 pi over 2. And that's going to give me 3 pi over 2. if you're adding 2 pi, that's not wrong. You would just have to add 2 pi again. So to save time, I just did it in one step. I just added 4 pi. Because the goal is to get a number between 0 and 2 pi when you're radians. You want to get a number between 0 and 360 when you're in degrees, so that it shows up on the unit circle. Okay, so tangent of 3 pi over 2, this one's just y over x. And if you locate, we just did 3 pi over 2 from above, so this is just going to be negative 1 over 0, which is just undefined. You cannot divide by 0. So I was going to make up one more example. But any questions before I do the last one on in the open space on the bottom left of this page? Okay, so for this last example, I'm going to draw a graph. And the problem is going to say negative 960 degrees. This would be the problem. So everything I'm doing in black is the problem. So because it's negative, it starts going down. So this is 360, 720, and then what do you add to 720 to get 960? That would be 240. So that would get you, let me see, that would get you to quadrant 2. Angle here would be 100, or it would be 60 degrees. So what I did in black would be the problem. And you want to figure out the 3 trig ratios. So negative 960, what I'm going to do to negative 960 is to get it so that it shows up on the unit circle, I would just add 1080. So that's 3 times 360. And that's going to give me 120 degrees. So when I'm doing my 6 trig ratios, I'm going to do sine. You could do negative 960, but you're going to be, I'll do negative 960 here, but it's based off of 120 degrees on the unit circle. So sine of negative 960. Cosine of negative 960, I should put the degree symbol. And tangent of negative 960. And then the reciprocals are going to be, let me separate this. So it's going to be cosecant of negative 960. Secant of negative 960. Sorry, it's a little messy. I probably should have given myself more space. And then cotangent of negative 960. But rather than using negative 960, I'm going to be using 120 instead, because 120 is what shows up on my unit circle. So if you locate 120 on your unit circle, just find the y-coordinate. That's going to give you sine. So at 120 degrees, your y-coordinate is square root of 3 over 2. That's going to give you your sine. At 120 degrees, you locate your x-coordinate. That's going to give you negative 1/2. Because in quadrant 2, cosine and tangent are both negative. It's all students. Only sine and its reciprocal is positive. So tangent is going to be y over x, which is negative square root of 3. So these are all answers here, so I can box them. So this is my sine. This is my cosine of the angle. This is my tangent. And then I just take the reciprocals. So this one's going to be 2 over square root of 3, which you can write as 2 square root of 3 over 3. Getting a little messy. So it says 2 over square root of 3, and then I times the top and the bottom by square root of 3. The reciprocal of negative 1/2 is negative 2. The reciprocal of negative square root of 3 is negative 1 over square root of 3. Then I'm just going to simplify that to negative square root of 3 over 3. And we are done with notes today.